Talking all about levels. Now, a level might not seem that impressive of a tool. It's a metal stick, sometimes plastic, sometimes made out of wood, and it's got a little bubble on the inside of it. There's a couple bubbles usually. There's one in the middle, and there's one on the either end. And so to understand the point of this thing and why it's so important is we have to talk about what it does first. All right, so a level, it does two things. You got to get the terms right. A level, if you hold it horizontally like this, the bubble in the middle is going to be telling you if something is level. Now, if you turn a level vertically, you still call it a level, but what it's going to tell you is if something is plumb. So again, horizontally is level, vertically is plumb. We don't call these things plums because we already got a fruit, right? So we got level, plumb. And so why is this so important? It all has to do with gravity. All right, so think, if you're standing somewhere and you're standing straight up and down, you're pretty stable, you're not going to get knocked over, right? The more you lean to one side, the further you go, your center of balance gets off place, and you're going to fall eventually. If I keep leaning, I'm going to fall over. And now imagine if you had more weight in your hand, the further off to the side you lean it, the more likely you are to fall over. So when we're building things, it has to do with gravity. And so when you are plumb, it means you are perfectly in line with gravity. You are running in a straight line down. And so your center of gravity is perfectly up and down. So think about on a building, you want all that weight going straight down to the earth. An example of that failing is think the Leaning Tower of Pisa. They're always afraid that thing's going to fall over. Why? Because it's not plumb, it's leaning. And the more it leans, they're afraid eventually the weight is going to be too much and it's going to make it fall over. All right. So plumb means perfectly in line with gravity. So if you are level, horizontal, that means you are running perpendicular to gravity at a perfect line. Perpendicular means a 90-degree angle. Another way to say that is square. And so this is square. If something has a square corner, it means 90 degrees. So plumb, level, and square all correspond with each other, right? If something is perfectly level and perfectly plumb, that means it is square. So also, if something is plumb and square, that means you know it is level. It's running at a 90 degree. So why is all this important? Again, it's gravity. You don't want your building to be leaning because it's going to fall over. You want the weight of that building to be going straight down. And why do you want things then to be level? Because you want to have things at 90-degree corners. Because again, if things are crooked, things are leaning, which means things are going to fall. And you can tell if something is out of level. If you had a marble and you put it on this table isn't level. The marble is going to roll off to the side, right? Some things, you don't want them to be level. So the concrete on your sidewalks or in your garage, usually your concrete is leaning. It's not level because you want water to run away in one direction, right? And so you need to know what's level so you know how to slope something. When something is perfectly level, I'm going to imagine I put this ball on here and it doesn't move, right? Imagine that's water. If something's level, water is just going to sit. It's not going to go anywhere. But watch what happens when I put a little bit of a slope on it. Again, I pick up the whole thing. Because it's out of level, the ball rolls to one side. And so when you're doing plumbing or you're doing, again, your concrete, where you want water to be moving in a direction, you don't want it to be level. You want it to be on a slope so that way gravity pulls it down. Because again, it's all about gravity. and something is level, gravity is still pulling it straight down. If it's sloped, gravity is pulling it on that angle to the side. Another thing you want to have it for is a doorway. Think your door is square, so if your door is perfectly square, it's a 90-degree, but then you have your door frame, if it's out of level and leaning to the side, what happens when your square door tries to swing? It's going to hit the corner and is not going to open nice and clean. And so that's why we want to have things that are perfectly level and perfectly plumb, because we want them to be structurally sound. You want all the weight going straight down, and we want everything at 90-degree corners. Nothing's leaning, everything will work functionally. And think about it, your plywood is all perfectly square, your drywall, all your materials are made to be square, so that way everything works. And that's why being plumb and vertical is... So here we are looking at the bubble of a level, and right now we're in the horizontal position, and so we are reading if something is level or not. I'm going to zoom in a little bit more, refocus the camera. All right, see how the bubble is perfectly between the lines? That means that right now the board that is sitting on is perfectly level. Now, watch what happens when I pick it up a little bit. Watch the bubble. So I'm picking up one side, I'm putting a slant on it, and watch what the bubble does. It goes to one side. The more I go, the bubble gets squeezed over more and more and more. All right, I'm gonna bring her back down. Watch what happens to the bubble. Just like that, we are back perfectly horizontal or perpendicular, right, to gravity. So, why is this important? How do we read this? Is we want to make sure it's perfectly in those lines. Some people, they say, oh, as long as it's basically in there, you're pretty close. But I'm about a 1/4 inch out just by being this close. And so in 2 feet, if I'm a 1/4 inch out, the further you go, if you go 20 feet down the row, just being this much out is going to add up to a lot. So 20 times 1/4 inches, so you're looking at 5 inches out by the time you get there to the other end, right? So you got to make sure you are perfectly between the lines. And so when we are looking to see if something is plumb, now my level is vertically up and down, so we're checking to see if something is plumb. It's the same thing. You want to get that bubble perfectly in the middle. If you lean it to a side, if we're crooked, we're no longer plumb, we're no longer inside. So you want to get perfectly plumb, perfectly between the lines to be plumb. So to show you how important being plumb and level is, I showed you this little graph to show you how just being a little bit out down the road can really mess you up. So for example, here's a nice perfectly level line. I put the level on that and drew it. So if we were at a perfect 90-degree, our angle, again, it will be perfectly 90. I can draw that here. So if we were at 90-degree, again, everything is transferred straight down. The distance is 0, right? But here's the problem. If we just take this little board and we just lean it a little bit, it's not that bad. When it's a little board, okay, we see the top of it's here. So our distance of it leaning out isn't that much when you just have a little board. The problem is when we have a house, we don't just have a little board, right? It gets bigger, right? And so a house, say your wall just was that little bit, as your walls get taller and it gets bigger, the problem is it's a straight line, right? Your walls are straight. So as that line continues in a crooked line, it takes us all the way over to here. So look how far now that distance is where the top of our walls is leaning over. It's not just a little bit, it's way over here. So in 4 inches or whatever this is, it only extends this much. But as soon as you increase the length to 16 inches, we're already this far out of plumb, right? And then so let's say a skyscraper, not just a house, a skyscraper, say it started out as foundation, it started out of level and out of plumb. And even though it doesn't seem that bad on the ground, by the time you get 100 or so stories, whatever it is up in the air, look how far out it is now. Look at that difference. The more you go in a straight line, the further away from this perfectly straight down line to gravity, right? With gravity. The taller you are, the further that distance gets. And look how far now the top is out from the bottom of the building. So what does that mean? The top of this part of the building is pulling straight down this way. And so what's going to happen? If it's leaning and it's being pulled down, it's going to want to keep falling this way. Whereas if you're being pulled down straight, you're going to have a big foundation right here. You're going to have a bunch of concrete, and so it can't go straight down. But if your building is leaning, it's going to want to continue in that motion, and over time, it's going to fall and collapse. So when you start out your foundation, you want to make sure it's perfect. And then your framing, it's perfect. Because if it's a 1/4 inch out in your foundation, and then you're another 1/4 inch out in your foundation or your walls, and then another 1/4, it all keeps growing. By the time you get to your roof, it's leaning off to one side like the Tower of Pisa, and it's going to fall down. Right? So if you want things to be built right, be built well, you need to make sure that they are plumb and that they are level. So to demonstrate what this looks like in real life, here's our classroom door that goes to our storage room. I got the level set up. One is reading if it's level. This one is reading if it's plumb. Let's zoom in and see how well they did. So you can see it's really close, but it is hugging the left line a little bit more than the right. So it's not quite plumb. It's really close, but not quite. And we're going to see how that affects the door in just a second. And now let's look at the level one. So the level bubble, this one's even better. Still, it's not quite. This one's a little bit to the right, but this one's really, really close. For the most part, it looks fine. But here's the thing, if you look real close, just being that little bit out of plumb, do you see this crack at the top of the door? See on this door how that crack looks the same distance. Now, this is the door we checked. Remember how it was just that little bit out of plumb? Notice the top of the line. Look, as you move across, it gets a little bit bigger. And then when we get to the top, right here, see that? The door is touching, it's rubbing a little bit. And all that is that jamb right here. This jamb is just that little bit out of plumb. And so if we took it and rotated it this way just slightly, it would fix it where it touches up there at the top. So just that little bit out of plumb affects how the door works. So I hope this helps you guys understand the importance of buildings being perfectly plumb and level, because it all has to do with gravity. We want the motion, all the weight, to go straight down. We don't want our buildings being pulled to the side. We also, when we walk through our house, we don't want to feel like we're walking down a hill, right? We want to feel like our house is perfectly flat. And so a level, the tool itself, very easy to use. You just have to line up that bubble and make sure everything is perfectly level and plumb. I will see you guys next time on the next episode of Tool Time!